We talked about pH in an earlier unit, but let's cover it one more time. pH scales are what we use to measure how acidic or how basic or how alkaline. It usually goes from 0 to 14 to represent the relative strengths of an acidic or basic solution. pH stands for the power of hydrogen, or concentration of hydrogen ions, measured as moles per liter, and now we know what that means. So remember, this square bracket is referring to the concentration of H plus in mole per liter. Okay. It's an inverse relationship. That means as one of the compounds goes up, for example, as the concentration of hydrogen ions increases, the pH will decrease. Or as this concentration of hydrogen decreases, pH increases. The formulas that we've used before, pH is equal to the negative, and that negative sign is hugely important. The negative log base of 10, don't worry about that, your calculator assumes that you're talking about log 10, concentration of hydrogen, or if you want concentration, it's 10 to the, again, insanely important negative pH. Pure water itself does split into ions a little bit, very, very weakly. Not every single one, 1 in 100, 1 in 1,000, whatever you want to say. One water molecule and another water molecule. This water molecule will lose one of its hydrogens. This water molecule will pick it up. We'll have H3O+, this is the hydronium, and we've got hydroxide. Hydronium cation, hydronium cation, and hydroxide. Okay. Pure water will have a concentration of hydronium equal to 1.0 times 10 to the negative 7. That means it has a pH of 7. Hydroxide, the concentration of hydroxide will be the same. For every 1 hydronium, we'll have exactly 1 hydroxide. So that means the power of hydroxide is also 7. Pure water is said to be neutral, or pH 7, because the two concentrations are equal. So it's neither acidic or basic, it's right in the middle. In an acidic solution, the concentration of hydrogen goes up above the concentration of hydroxide, or the hydroxide concentration goes down, so relatively this is larger, but something stays the same. If you multiply the two concentrations together, the concentration of H plus and the concentration of OH negative, you will always get a number of 1 times 10 to the negative 14. Always, always, always. Similarly, in basic solution or an alkaline solution, either the concentration of hydrogen has gone down or the concentration of hydroxide has gone up, but if you multiply the two together, you always get the same. And the formulas for hydroxide are similar. The power of hydroxide is equal to the negative log of the concentration of hydroxide, and concentration of OH negative is equal to negative log POH. Oops. Shoot.